Over the years, I have come to appreciate QML as an excellent tool for building large desktop applications. Not only can we build cool looking UIs using QML, we can also build the kind of UIs we were building using graphics view and traditional widgets. In this talk, I am going to walk you through some of the best practices that I have discovered, highlight why model view thinking is so important, walk you through parts of the source code of a free and open source desktop app that I've been working on to highlight the various ways in which we use model view there, and also talk about some ideas for optimization. Good morning, good afternoon, good evening. Welcome to my presentation on building beautiful desktop applications using QML. I intend to make best use of the 45 minutes we have together to not only inform but also to create a sense of excitement and enthusiasm about using QML for building large desktop applications. My name is Prashanth Udupa and I'm a software developer from Bengaluru, India. My love affair with Qt goes back 20 years. In 2001, I used Qt for a university project. I have since been using Qt both personally and professionally. For the most part of my career, I've been helping companies make best use of Qt for building their products. I also have a few open source projects to my credit: BTK Designer, GCF, and quite recently, Scrite. In fact, much of the content for this talk is based on what I learned while building Scribe, a free and open source desktop screenwriting app from Teriflex. It is immensely satisfying for me to know that close to 2,000 writers from all around the world are using Scribe as of today. In fact, I personally know 10 filmmakers who have written the screenplay of their next film using Scribe during the lockdowns last year. As a software developer who loves to build apps using Qt, the most exciting thing about Scribe is that its UI is completely developed using QML. There is not a single widget in the entire app. We took baby steps and started small. The first public beta of Scrite was released only 2 weeks after the project was started. And even at that point, one could use the app to write full feature-length film screenplays and even export it to PDF. And that brings me to the very first point I want to make in my presentation today. With QML, you can rapidly prototype your applications. Complex user interfaces, which would have taken weeks and months to develop using widgets, can now be developed using QML in a matter of days, hours even. By using QML, we were able to put Scribe in the hands of our users in a matter of weeks. We have since been collecting feedback, polishing the UI, building new features, making the app look and function better and better with each update. In fact, one of our users, who is a film actor and a budding director, who also used to be a UI designer in the past, loved the product so much that he went out of his way to contribute UI design mockups to Scribe. When the app used to look like this, he created a mockup and suggested that we upgrade the UI of Scribe and make it look a lot like this: a flat user interface design in line with a lot of modern interfaces. Around the same time, some of our users were requesting for industry standard formatting. While we were building support for it, we felt that since many industry standard apps featured a ruler, we should have one too. So Surya updated his mockup to include the ruler. So we had to upgrade the user interface of the app from looking like this to looking like this. And we were able to upgrade the UI without breaking anything in just about 5 days. A few iterations later, the app started to look a lot more modern than before. We were even able to introduce UI elements like pull-out panels, which would animate out when clicked on and which would animate away when clicked on again. You can imagine how difficult this would have been in the widgets world. By using QML, this was just a few days of work. We were iterating rapidly, and some of our users were surprised with the pace of progress. This is what the app looks like as of today. Along with changes to the UI, we have added a lot of new features while maintaining full backward compatibility with documents created using the previous versions of the app. In effect, we are able to carry forward all business logic And that brings me to the second point I want to make in my presentation today. In the Scribe project, we were able to update the UI independently from the backend layers of the app. This allowed us to create new features in the backend layer and improve the presentation of these features in the UI effectively. This was possible entirely because with QML, you get to have a clean separation between UI and business logic. The reason for this is very simple. The UI is written in QML, a language very different from what we use to write the business logic, which is C++. And that means these two will end up being distinct layers with a proper interface that leads to cleaner code and better architecture. In my opinion, this is the killer feature of Qt Quick and QML. Until Scrite, I had never really worked on a fully fledged desktop application using QML. So I obviously had questions and concerns, much like any developer who comes from the widgets world would. But the first question obviously was, can I show a main window in QML? Can I show menu bars and menus and toolbars and status bar and central widget? What about dialog boxes? How do I show a dialog box in QML? Well, I've seen a lot of examples in QML which shows lists and grids, but what about things like graphs? What about graphics view like UIs? Is it even possible in QML? Does drag and drop really work? How about multimedia? Can I play back an audio or video file in QML? After having worked on Scribe for close to a year, I have had an opportunity to discover answers to a lot of these questions for myself experientially. Well, the short answer to these questions is yes, it's possible to build the same kind of UIs that we are building using widgets. In fact, maybe we can even do better, but it's a little bit different with QML. There are a handful of best practices that one can adopt to make really good use of QML on the desktop. But before I get to that, I want to walk you through the UI of Scribe so that you can see for yourself that you can really build widgets-like desktop applications using QML and maybe even do it delightfully better. This is the main window of Scribe. As you can see, the layout looks very similar to what a Q main window would offer. We have a toolbar on the top, we have a central widget area here, and we also have a status bar. In fact, we even have custom controls on the status bar. We have a lock icon to the extreme left, the status message right next to it, and a zoom slider control to the extreme right. We don't use a menu bar in Scribe because we don't really need it. But QML does offer a menu bar component for use in your desktop applications. However, we make use of menu in a lot of places within Scribe. For example, here we have a scene-specific menu. Notice how we are able to show custom controls in these menus. In fact, in some menus, we even show more than one label against each menu item. So, main window in QML, check. In the widgets world, you have to subclass from QDialog if you have to create a dialog box. But with QML, you get a lot of flexibility. Now, we use that flexibility to create interesting looking dialog boxes. Let me show you a dialog box in Scribe. I'm going to click on this button here and pull out the Script dialog box. Script is where you can select and download screenplays of popular films. Notice how the title bar of the dialog box looks very different. The panels in the dialog box looks different. The tooltips also looks very different. And did you notice that when I clicked on the button, the dialog box animated out? Now when I cancel this dialog box, the dialog box animates back into the button. Let me slow this animation down. Now I'm going to click on the Script button once again. Notice how the dialog box slowly comes out of the button to the top. You also can notice as the dialog box's size increased, the background became more and more opaque. Now I'm going to click on the cancel button. Now as the dialog box moves back into the button, the background becomes more and more transparent. Now, while this animation looks very cool for the developer to implement, it provides a very subtle information to the user. It lets the user know where a particular dialog box came from. Dialog boxes don't animate in and out of buttons like this by default in QML. This animation was custom written for the Scribe project. But I do want to underline one thing. It's possible to build custom user interfaces like this. It would have been very difficult to accomplish this in the widgets world. The second version of Qt Quick Controls module comes bundled with a dialog component that allows you to create normal and modal dialog boxes like the way you would in the widgets world. But in this demo, I wanted to showcase that it's also possible to create new and unique looking dialog boxes for your QML applications. In summary, dialog boxes in QML, check. So what about graphics view? Scrite allows writers to visually capture the structure and flow of their stories. When we switch to the structure tab, we can see that there are three areas. These three areas are best explained with the help of a screenplay. Let me go ahead and open a screenplay now. I'm going to open the screenplay of Punyakoti. Now that we have the screenplay open, let me switch to the structure tab. Well, we have three areas here. The timeline area down below is where the writer can sequence the scenes that make up the screenplay. The screenplay editor on the right here is where the writer can view and edit the contents of the scene. The structure canvas is where the writer can plot the structure of the screenplay. In this particular screenplay, the writer has split the index cards that make up his screenplay into 4 acts and has placed it in a horizontal layout, much like the writer would have done if they were using post-it notes on a beat board in the writer's room. We can zoom in and zoom out in the structure canvas, pan, move the index cards around, place them wherever we want. We can even add annotations. You can add a text annotation, image, rectangle, and even a website link. Let's say I want to add an annotation that makes sense to this particular screenplay here. This particular film talks about deforestation, and maybe I want to add a reference to that particular incident in our state. So this way we can add a lot of information on the structure canvas and make it rich. If I was developing Scribe using widgets, then naturally I would have used the graphics view framework for the structure canvas. In QML, we don't have graphics view, but we have tools that helps us create UIs similar to what we would using graphics view. In effect, graphics view like UIs in QML, check. What about drag and drop? Let's say I wanted to add a new scene in between these two scenes in the screenplay. So I can just go here, right click, create a new scene, place it here, and it says this is an unused scene, and I want to drag it in between these two existing scenes. So if I click on this, it lets me know what is the scene that we're talking about, right? So I can just go here and drag this particular scene so that it fits in between the two scenes in question. So as soon as I drop it, you'll notice that the structure canvas is now updated. The arrows show that the flow of story is now from this index card to this index card and then here. And you'll notice that even in the screenplay editor, there's a blank scene in between the two existing scenes. So drag and drop in QML, check. Okay, so what about graphs? Well, we all know that there's a charting module in Qt that helps us draw line and bar graphs and pie charts even, but I want to show something different. Scrite allows writers to capture relationships between various characters in the screenplay. Here we have a character. Let's go ahead and add a few relationships around her. Now, when I click on the Create Relationships button, you'll notice that Scrite immediately constructs a force-directed graph and presents it to us, which has captured all the relationships around Devasena. I can move each of these nodes, and you'll notice that the graph automatically updates itself. What's going on in the background is that we have a data model that simply captures the nodes and edges that makes up this graph. Whenever I interact with this graph, the data model gets updated, which causes the view to get updated. So graphs in QML, check. But what about multimedia? Qt already provides a multimedia module using which we can play back audio and video content. We use that in Scribe to offer a feature that lets writers sync the playback of the film with their screenplay. Here we have the screenplay and film video of a particular film loaded. I've already synced the time offsets for scene heading, action, and a few dialogue paragraphs. Now all I have to do is to check the auto scroll button and then play back the video. This will cause the screenplay to scroll in sync with the video playback. Let me quickly show that to you.
ಎರಡು ಕಾಪಿ ಮಾಡಿಸಿ.
Yes, sir.
It's that simple. Multimedia in QML, check. Is it possible to build desktop apps using QML? The answer is yes, but the approach is a little bit different. And there are best practices. And that's what I want to talk about next. Like I said before, there are two distinct layers in Qt Quick and QML applications. One is the UI layer written in QML, the other is the business logic layer written in C++. And there is a clear, well-defined interface for communication between the two. Mastering this interface is essential to writing good Qt Quick and QML applications. A key aspect of this interface is model view. Broadly speaking, we can look at the business logic layer as model and the QML UI layer as view. Models in business logic layer are built using one or more of the following C++ classes: QObject or QMetaObject, container classes like QVariantList, QJSONArray, QList, and specialized model classes like QAbstractItemModel and subclasses. Views in QML are built using one or more of the following QML features: dynamic property binding, and elements like repeater, list view, and grid view. In my opinion, if we just understand this, we will get very far in QML. Let me show you a few places in Scrite code where we have leveraged this. For a writer, it's really important to know the number of pages their screenplay spans. This is because each page of the screenplay roughly translates to 1 minute of screen time. In Scribe, we show the current page count on the status bar, and this gets updated as the screenplay is being written. For example, I'm going to paste some content now, and you'll notice that the page count immediately got updated to say there are now 2 pages in the screenplay. In fact, we do something even more delightful. As the screenplay is being written, we make use of a QText document instance behind the scenes to compute the page layout, and then we make use of the current cursor position to find out the current page number and the current time under the cursor. Notice how the current page number is getting updated as I scroll the cursor up and down, and notice how the current time is getting updated on the top as I scroll the cursor up and down. And this is especially useful while working on large screenplays. Now, as you can imagine, there are two aspects to this functionality. One is the business logic aspect, which involves doing the page layout, computing the page count, the current page, and the current time. The other is the UI aspect, which involves showing the page count, current page, and current time. So the business logic layer will have to be implemented in C++, while the display or the UI has to be implemented in QML. Let's look at the business logic layer first. On the C++ side, we have a class called a screenplay text document. This class performs the page layouting, and therefore it is best suited for computing the total page count, total time, current page, and current time. So we have the C++ class. All of these attributes are captured as properties. Page count is a property, and so is current page, current position, total time as string, current time as string. One thing that I want you to observe in each of these property declarations is that they have something called as a notification signal tagged along with them. For example, the page count property has a page count changed signal associated with it. Whenever page count changed is emitted, page count as a property is considered to have gotten altered. Next, we export the entire screenplay text document class to the QML side using QML register type property. And now let's look at the UI layer. First, we start by creating an instance of the screenplay text document class in QML. Now, before I show you how we make use of the properties exported by the screenplay text document class, I want to quickly show you one slide from the Qt training material. Properties in QML are bound. That means they are not just initial assignments. The expressions on the right hand side are re-evaluated when needed. For example, in this particular case, the value of the width property is recomputed whenever the value of the height property is changed. And the way QML engine knows when to recompute properties is by detecting the notification signal associated with the property. In this case, whenever the height changed signal is emitted, the value of width property is recomputed. So let's get back to to our QML code in Scrite. We have a status bar, and within the status bar, we have this text called as page number display. Notice how the property value of text property in the text QML element is constructed as a combination of current page, page count, total time as string, current time as string property values from the screenplay text document. So whenever any of these properties are changed, which is getting detected by the notification signal, then the value of the text property is getting recomputed. Now, same is the case with the global time display that you see on the toolbar. There is a text called as current time label, whose text property value is computed using the current time property value. So whenever the current time change signal is emitted, this entire text value is getting recomputed. Now this gives you a sense of the Qt Quick interface that allows us to communicate between the C++ backend and the UI frontend, which is in QML. In summary, properties in QObjects and dynamically binding those properties in QML is one kind of model view infrastructure provided by the Qt Quick interface. Let me show you another place in the app where we use model view to do something delightful. In Scrite, we aggregate character names against each scene. This data is especially useful while generating reports. For example, we can pull out dialogues for a specific character. This report can then be handed over to the actor as dialogue notes. We can even generate a simple scene versus character table report. This report is especially useful during pre-production. The report contains characters in each column and scenes in each row, with a marker in the cell signifying the character's presence in each scene. So it's important that we capture character names against each scene. And we do it as the user types content in Scrite. Here I'm going to add a new scene. Let me provide a simple scene heading and type some action text. Now, as I type dialogues, notice how the names of the characters will appear in this list here. And the moment I type the second dialogue, the duplicate name disappears. Now it must be possible for me to add mute characters to the scene. Mute characters are those that don't have a dialogue but are present in the scene anyway. Notice how mute characters have a cross button because we should be able to delete mute characters from the list. But the moment I add a dialogue for the mute character, you can notice that the cross button disappears. This appears like a lot of complex functionality, but it's pretty simple to implement once we use model view. Let me show you how we do that in Scrite. Let's start by looking at the business logic aspect of this functionality. So we'll have to look at C++ code for this. Now here we have a class called a scene, which represents one scene in the screenplay. Now this class has a property called as has characters, which returns true if there are characters in the scene and false otherwise. We have another property called as character names, whose data type is QString_list. This returns a list of all the characters in the scene. And then we have a few functions which allows us to manipulate mute characters in the scene. Now notice how we have marked each of these functions using the macro q_invocable. Functions marked using this macro can be dereferenced from QML. Now this was about the C++ side of things, or the business logic. Now let's look at the QML side of things, which is the UI layer. Here we are making use of a flow layout. And the reason why we are making use of flow layout is because we want the character names to buckle if there are too many character names in a particular scene. Notice how inside the flow layout, the first item that we place is the character's text, which is in boldface font. And then we make use of a repeater. The model property of the repeater is set to the character names provided by the scene. Now what the repeater then does is it loops over each name in this QString list and creates an instance of tag text for every single character. Now tag text is a custom item written in the Scrite project. This custom item draws the bubble around the character name and also renders the character name inside it. It's also responsible for showing the close button for mute characters. Now we can't show the close button for all of the characters, so there is a property called as closable. The value of this property is set to true if the scene says that a particular character name is a mute character. What about adding new characters to this list? For that, we have an editor which is loaded on demand by the new character input loader. Notice how the value of the active property in this loader is set to false by default. Whenever the user clicks on the mouse area associated with the plus icon, it's at that point the loader becomes active and we end up accepting the mute character from this loader. The new character input loader is basically providing a text input area. Now, whenever the editing is finished on the text input area, notice how we are calling the add mute character function inside the scene class. Now, this was marked as an invocable function. This causes the addition of whatever new character name we have typed in the editor as a mute character into the scene. In summary, we are making use of repeater as the view aspect of the model view construct to offer this functionality. The model being scene.character names, which is a string list. Now I've shown you two features in Scribe. One is the current page and time. The second one is the scene character list. In both these cases, we've observed the use of model view. But truth be told, it's obvious that we should use model view for both of these features. If there is only one thing I want to leave you with at the end of this presentation, it is this. To make really good use of Qt Quick and QML, we have to break down everything into a model view problem. Not just the obvious ones, but everything should be broken down into a model view problem. Every problem, every feature has to be broken down into two parts, a model or data part and view or UI part. I now want to show you a few features in Scribe where at first glance, the usage of model view may not be obvious, but you have actually used it. Scribe allows writers to generate various reports from their screenplay. For example, we can generate the character report, select one or more characters, and extract a report of all the dialogues for the selected characters. As you can see in this PDF here, we only have dialogues for the selected characters extracted. We can also generate a report called character screenplay, which would contain entire scenes of a specific character or characters. As you can see in this PDF, we only have the scenes in which Carolyn character is present with her dialogues highlighted in yellow. Or we could generate a location screenplay, which is entire scenes at a specified location or locations. Here we can see all of the scenes in the specified locations, which is Jyoti's house and balcony. We've already seen scene character matrix. Let's look at screenplay subset. This allows us to extract complete scenes for a specific subset of scenes. Here we are selecting all the interior scenes that happen at night. There are totally 22 of them, and we can generate a report that contains entire scenes that happen inside and at night. Now you may be wondering, where is model view in all of this? Let me get to that now. Each of the dialog boxes that we see against various report generators, let's observe how they look. All the dialog boxes have panels. Here we have basic and characters, and each of these panels contain a few control knobs. Let's look at another report. The location screenplay report has basic PDF options and locations. And again, each of these panels have some control knobs in them. Let's look at one more. Screenplay subset also has 3 panels and a few control knobs in them. Now to answer the question, where is model view? It's right here. The dialog boxes are the view, and the model is the meta object information provided by the report generator classes. Once again, let's start by looking at the model part first, which is going to be in C++. Here we are looking at the character screenplay report class. An instance of this class gets created whenever we want to generate the character screenplay report. Notice how we are capturing the title and description as Q_class info. The title and description are picked up from here and shown on the dialog box. The control knobs are captured as properties. Here we see include notes, highlight dialogue, and character names captured as properties. In addition to just capturing them as properties, we are making use of q underscore class info for each property to provide some additional information. For example, for include notes, we're saying it should be presented within a group of configuration knobs called as characters. The label to use for the editor that configures this particular property should be include character notes, and the editor to use is checkbox. Same is the case with highlight dialogues as a property as well. But for character names, you're saying make use of an editor called as multiple character name selector to present the configuration knob associated with character names. The base class of character screenplay report, which is abstract screenplay subset report, has a bunch of properties of its own. And notice how we are presenting the configuration knobs from this character inside the basic field group. And we also have a few properties that should show up within the PDF options group. All of this information is captured using q underscore class info. Let's now look at a function called as object configuration form info within the application class. This function accepts as parameter a q object and it returns a QJSON object. What we do inside this function is query the meta object of the object that was just passed as parameter, and notice how we query the class infos for title and description within the q object and then store it as title and description attributes in the JSON object that we return from this function. Now, the main thing that we do in this function is we loop over all of the properties inside this object, query the meta property for each of it, and then we create a QJSON object for every property that we find inside this Q object. We store the meta information that we dropped as hints in the C++ class declaration. For example, the screenplay subset report has a property called scene numbers. Notice how we are making use of Q class info key scene numbers under field group to provide the value as scenes, which then gets stored inside the group attribute of the QJSON object. Same is the case with field label, which will get stored under label, and the field editor gets stored under editor attribute inside the QJSON object. This way, we loop through all of the properties and then create JSON objects for each property that we find. And these JSON objects are aggregated inside the fields and grouped fields array within the return QJSON object. Let's now look at what the return JSON object looks like for an instance of screenplay subset report class. This is how the JSON object looks like for an instance of a screenplay subset report class. Notice the value of title and description. These values are picked up from the Q class info statements inside the class declaration. You can also notice the group fields consist of 3 groups. The last group is expanded here, but if we expand the other groups, we can notice that there is also a PDF and basic options group. Now, if we look at the dialog box that is generated for the screenplay subset report generator, you'll notice that the data that we see in the dialog box is picked up from this JSON object. Let's now look at the view aspect. We're looking at the report generator configuration.qml. An instance of this item gets created whenever you want to show the report generator configuration dialog box. Now you'll notice that in the component.onCompleted signal handler, we are creating an instance of the report by name. And once we get the report generator, we are calling this function called as configuration form info. The implementation of this function within the report generator class actually calls the object configuration form info function within application. Now, this was the function that we just looked at a little while ago. Now that we have data and also have figured out a way to get the data into QML, all that's left for us to do is to render this data in the dialog box. Here we're looking at the code which renders the title and description from the JSON object on the dialog box. Here we're looking at a repeater that loops through all of the grouped fields, and within each group we use another repeater to loop through all of the fields in the group and create editor items for each field. So we have to make use of some kind of a factory pattern. Notice that we are making use of loader to actually load a different field for each editor. Here we can see how the load field editor is creating a different editor item for different fields. So in effect, we are interpreting the meta object information provided by the report generator classes as a model and packaging that into a JSON object and then rendering that information in the view using QML. Let's step back and review the model view infrastructure we have covered in the presentation so far. On the view side, we have seen examples of property binding, repeater, and list view. And on the model side, we have seen an example of QObject and QMetaObject, container classes like QJSONArray and QList, specifically the QStringList. One last thing that's left for us to cover is an example of a specialized model class, which is QAbstractItemModel and subclasses. One of the most important data sources in Scrite is the screenplay itself. And we provide access to the screenplay data through the abstract item model interface. If you look at it, a screenplay is simply a list of scenes, and that makes it an ideal candidate for a list model. And that's precisely what we have done. In Scribe, we have a class called as screenplay, which houses a list of screenplay elements. Each screenplay element is either an act break or an actual scene. When it's an actual scene, it holds a pointer to a scene object, which houses a list of scene elements. It also has a pointer to a special paragraph called a scene heading. The screenplay object is usually accessed through a screenplay adapter. The reasons for doing so is beyond the scope of this presentation. But what's important is that the screenplay adapter is an identity proxy model, which makes it another model. So to render the screenplay and make it editable, all we have to do is to use a list view component in the UI with its model as the screenplay adapter and a text edit as a delegate to edit each scene. And that's precisely what we have done in Scrite. We are now looking at the screenplay editor.qml file. An instance of the item in this file is created whenever the screenplay editor interface has to be shown to the user. Notice the use of list view component with its model as the screenplay adapter and the delegate as a loader. The source component of this delegate is either a content component or a break component, depending on the type of screenplay element that is currently being presented to the user. And notice especially that the active property of this loader is set to false. And this is because we delay the loading of the source component in this delegate by just a few milliseconds. In that time, we show a placeholder image conveying to the user that there is some scene content even though it's not currently rendered. Let me show that to you in the app now. Now, I'm going to scroll rapidly through the screenplay editor and you'll notice that the scenes initially show a placeholder image for a few milliseconds before the actual content is loaded. This allows the scrolling to remain smooth without impacting the user's experience of the app. And we have to do that because the delegates are quite heavy and they take some time to load and unload, and we would much rather not do that during the critical scrolling time. Now, the scene list on the left is also another list view on the exact same screenplay adapter. Instead of showing entire scenes, we only show the scene headings. I can click on any of the scenes in this list and rapidly scroll to that scene in the screenplay editor. In fact, I get a surprise functionality for free. Notice what happens when I edit the scene heading in the screenplay editor for this scene. The moment I hit enter, the same scene heading shows up in the scene list as well. Why? Because they're both hooked up to the exact same model. So in this feature, we are making use of a specialized model class, which is the QAbstractItemModel. The screenplay and scene data is captured as list models and are accessed through the screenplay adapter class. All of these are implementing the QAbstractItemModel interface. So this is in C++ and it makes up the model aspect of this feature. On the view side, we're making use of list view and loaded elements to render the contents of the screenplay. And all of this is written in QML. Again, you can notice the neat separation between the model and view layers, and the communication between the two is enabled by the Qt Quick interface. We have covered all aspects of the model view infrastructure that I set out to cover in this presentation. But I do have one more thing to talk about. We have seen enough and more examples and demos of model view, not just in this presentation, but elsewhere as well. But in almost all examples and all demos, each view has exactly one model. But what about views that require multiple models? In use cases like medical visualization and circuit schematic editor, we need to show data from multiple models in a single view. For example, in a circuit schematic editor, we have a view that shows multiple layers of data, like components and annotations and connectors and so on. Anytime we have a canvas-like view that is showing multiple layers of data, we have a model view construct where a single view is showing data from multiple models. Such problems are usually broken down as follows. A single view is considered to have multiple layers, where each layer is showing data from a single model. When we try to implement this using Qt and QML, the view will be implemented using flickable or a scroll area and a pinch handler. Each layer will be implemented using repeaters, and the models will simply be C++ models. So all the models will be in the business logic or the data layer, which is in C++. All of the views will be in the UI or the QML layer. The structure canvas in Scrite looks a lot like this. As I said previously in the presentation, the structure canvas sports a graphics view like UI. We show a lot of layers on this UI. We can zoom in and zoom out at any point. This is very much like a graphics view. Now there are multiple layers of data in this canvas. The elements layer, the annotations layer, the groups layer, and then the stacks layer. Multiple layers of data is shown in one view. Let's now look at the model and view aspect of the multi-layer display, which is the structure canvas. First, let's look at the business logic layer, which is going to be in C++. There's a class called as structure, which provides access through properties to various models that we show in different layers on the structure canvas. The first property that we're going to talk about is the elements model property. This property provides us access to a list model of structure element objects. Now, each structure element object has a bunch of properties that provides us the X, Y, width, and height of each structure element. Now, structure element is basically an index card on the structure canvas. Now, the X, Y, width, height properties tells us where in the structure canvas the index card should actually be rendered. Similarly, we have two other properties. One is the annotations model. The other is the element stacks model. These provide access to annotations and element stacks that show up on the structure canvas. So that was the business logic or the models layer in C++. Let's now look at the UI layer, which is in QML. We make use of repeater to go over all the elements in the elements model and render them on the canvas. We make use of another repeater to go over all the annotations, but we're accessing the annotations through something called as an annotations filter model. I'm going to come back and explain why we do that in just a bit. But then coming back, we use another repeater to go over all of the group boxes in canvas.beats and render them as such on the structure canvas. And finally, we make use of another repeater to go over all of the element stacks and render them as tabs. Now, each tab is rendered using an item called as simple tab bar item. We have used repeaters to render data from multiple models on a single view. We've still not covered one aspect of this entire slide, and that is the view part itself. The view itself is implemented using the scroll area component, which is a custom component written in Scribe that is built on top of the flickable component provided by Qt. We also make use of another built-in item called as pinch handler, which allows us to implement the pinch zoom functionality for our structure canvas. This is especially useful if you have a laptop with a trackpad. You can use two fingers to zoom in and zoom out. In summary, whenever we have data to be rendered from multiple models on a single view, this is a design pattern that we could use. A repeater for each layer that renders data from different models on a single view. And finally, I want to talk about an optimization technique for rendering views with large number of items. Built-in views like list view and grid view creates only as many delegates as needed. Let me show you what I mean by that. Here we have an open screenplay. As I've mentioned before, the scene list panel on the left and the screenplay editor in the middle are both built using the built-in list view component from QML. The built-in list view component ensures that it creates only as many delegates as visible on the screen. Now this is important because we don't want to create delegates for all of the scenes and keep them in memory when only a subset of it is visible. I have now launched Scrite by setting the QST visualize environment variable set to overdraw. This will cause Qt to show us a 3D view of the entire QML scene. This feature is very useful for debugging Qt Quick and QML applications. Notice the list view component used in both the screenplay list panel on the left and the screenplay editor in the middle. They only create as many delegates as are visible on the screen. While built-in views like list view and grid view are smart, repeater isn't. Repeater simply creates one delegate for each item served by the model. This means that if the model is serving 20,000 items, repeater creates 20,000 instances of the delegate. Now that's bad news if you're using repeater to render a large model on a canvas. You end up creating too many items that are not even visible on the screen. Now, rather than hooking up the source model directly with the repeater, we can introduce a proxy model in between. Now, this proxy model is also written in C++. The function of this proxy model is to filter items based on whether they show up within the viewport rectangle or not, or at the very least, toggle visibility. This way, we ensure that we don't throw too many items to the render queue or even the memory. That's precisely what the annotations filter model does. With the annotations filter model turned off, all the annotations are created on the canvas, whether or not they are visible to the user. By turning on the annotations filter model, we ensure that only those annotations that have a chance of being visible in the viewport are created in memory. The others are destroyed as soon as possible. I must say this, proxy models like this are not generic. There isn't something called as a one-size-fits-all kind of a proxy model. There is a lot of trial and error involved before one can get it right. But it's a useful optimization technique to keep in mind. So to sum up, by using QML, you can rapidly prototype your applications. You can change the UI and business logic independent of each other. And that is because in QML, there is a proper separation between the UI and business logic layers. And to really make good use of it, we have to break down everything into a model view problem. And certain optimization techniques can be employed to improve the performance and memory consumption of QML applications on the desktop. Like I said before, much of the content for this talk is based on the work I've been doing on the Scribe project. Please visit scribe.io today, download a copy of the app, take it for a spin, and post your feedback on the forum in our website. The complete source code of Scribe is available on GitHub. You can visit the URL that you see on the screen and clone a copy of the code today and take a look at it. If you like what you see and you feel like participating, drop me an email or send me a pull request. I hope you found this presentation useful and that it was worth your time. If you post about it on social media, may I request that you use hashtag Scribe and hashtag QML in your posts and also tag me. And finally, while signing off, I just want to say have a wonderful time as you build beautiful desktop applications using QML. Thank you so much for your time today. Goodbye.